Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
A pleasure for me to welcome Brent Rowe. Brent Rowe comes from RTI and is a senior economist there and has done very interesting work on understanding software economics. How much does bugs cost? How much does the transition from IPv4 to IPv6 cost? And he will talk today about analyzing investments in innovation, looking into implications for private companies as well as for the government. Thanks a lot, Brent, for coming by.
All right. Thanks, Wolfram. Okay, so my name is Brent Rowe. I'm a senior economist at RTI. I work in our San Francisco office. A brief little bit about RTI. We are a not-for-profit research institution formed originally by Duke, NC State, and UNC Chapel Hill as a place with a similar mission to MSR. Our mission is turning knowledge into practice, which I think is fairly similar to what your mission is here. Over that past 50 years or so, we've done a great deal of work in public health, in technology innovation, as well as technology management and understanding of economic issues and social issues surrounding public health and new technologies, as well as international development. So some of the key areas we're involved in. We've got about 3,000 staff worldwide, the majority in North Carolina, working on lots of different issues with lots of different backgrounds. So just a little information for you on kind of where I'm coming from. So what I'm going to try and talk about today is a few different areas. One is kind of starting out thinking about just how to analyze innovation. And I'll start kind of thinking about this from private perspective, and then talk about where there may be a role for government. A lot of the work that we've done is focused on, for NIST and for other organizations in the government, where their role might be, how the government might be to support industry in terms of technology policy, be that regulation, subsidization, or in this case, new standards, new kind of supporting infrastructure. And so I'll talk a little bit about why that role might be necessary or might be useful in certain cases, what might motivate a role for government. Talk a little bit about some studies we've done, such as IPv6, such as some work we did on software testing and RBAC, role-based access control. And then I'll talk about some future kind of research needs in the software assurance type of space. Okay, so starting out with kind of a framework for evaluating private investment. So I think pretty much all decisions that are made within an innovation-focused organization could benefit from a cost-benefit mentality. But that doesn't mean that all decisions should use a cost-benefit mentality. I think the thresholds that you need to think about when deciding how rigorous to do an analysis of any type of investment, be it spending a small number of hours on a new project or be it devoting an entire group to a new project, I think depends on the organization and really depends on whatever thresholds you'd like to set in terms of how great those thresholds are, what the benefits might be. But I think more organizations could benefit from spending more time on using cost-benefit and economic frameworks for thinking about everyday decisions. I think a key feature of any cost-benefit analysis, any economic analysis, is that you don't have to solve everything. I think lots of organizations shy away from doing economic analysis and cost-benefit analysis because they don't feel comfortable estimating certain components of that analysis. What you should do is set assumptions, right? So there's certain things that are going to be very difficult to understand, and that's okay. Setting those things to the side and focusing on what you can analyze is a good method to do some kind of introductory work on, or in some cases, for smaller decisions, that could be all the work you do, is make some assumptions and then do a cost-benefit analysis of what makes sense. So that's my spiel for why more economic analysis should be done. So,
Could you,
sure.
Could you explain the three little bullets there?
So these are really just kind of placeholders. So it depends on the organization and what numbers make sense. So I kind of threw in these numbers thinking about the size of Microsoft and MSR. So potentially under a $50,000 investment, you may not want to spend a lot of time analyzing, and maybe that should be 25. You know, it's kind of up to you to decide, but you may just want to do some qualitative analysis. So think about who's going to be affected, and I'll go through the different pieces of this type of analysis, but who would be affected by a decision, what the different cost factors might look like, and just do a rough calculation of what the cost benefit might be. Once you get to a little bit larger investment, you might want to actually go out and conduct some interviews or do some type of data collection from affected stakeholders, be that internal, external, to see how your investment, both how much the investment might cost internally, as well as what the implications would be if it's successful or if it's not successful, right, on people both internally and externally. And then if it's a much larger investment, obviously you should spend even more time thinking about that. So really my suggestion would be to ramp that up, to set certain thresholds in terms of the amount of time and effort you put into the actual economic analysis. So if you're spending weeks and weeks on an economic analysis for a project that's very small, that doesn't make a lot of sense, because then you're just increasing the cost of the investment. Okay, so you've decided that you're going to do an economic analysis or a cost-benefit analysis of some sort. What are the kind of key steps you might think about? So one would be assess the components. So this is who are the stakeholders, what are the different costs, metrics, what do you really want to succeed, and how likely is success? Then spell out within each of these what are all the different cost and benefit metrics that you'll think of, and I'll step through these in a little more detail. Collect that data, analyze that data, and make the decision. Fairly simple, but within each of these, it can be a quite rigorous process depending on how much time you want to spend. So I set as kind of an example, should MSR invest in research in a new model to improve software testing? Okay, so I'll kind of go through here what that might look like. So assess the components. What's the research aim? What's the goal? What are you actually trying to change? What does success look like? Who are the potentially affected stakeholders? So you've got the staff conducting the research, you've got the staff who develop software, the staff who evaluate software, pre-release, and then you've got all the post-release costs. Then you also have business customers, then you also have home customers. My suggestion here, and this seems very kind of trivial and simplistic, my suggestion here is that even something that's fairly early stage, kind of a basic research project, should at least think about all of these potential stakeholders. Even if a project seems like it may or may not work in its very early stage, thinking about these stakeholders could make you decide that a project isn't worth investing in very early, and then money is saved. Similarly, what are the alternative investments, right? So maybe MSR or Microsoft more broadly would invest in some new technology that would potentially make everyone more productive. So thinking about what else could be invested in at some level is a useful way to say, is this a good investment? So who are the stakeholders? What else could we do with this money? All right, so thinking about the actual cost-benefit metrics underneath that. So what are the explicit metrics for the investment? So you've got the research cost to MSR, and you've got the cost to all the other staff that might be affected. So developer staff, if you have the time, interviewing, surveys, that sort of thing, to try to get actual data on what that impact might look like. Because maybe the impact is so great or so small that even if the research is successful, it doesn't matter. Cost to other groups, and this could be up or down. So maybe pre-release or post-release, you end up figuring out during this process of seeing what the costs and benefits are that it's the reverse of what you thought, right? So maybe you think that the costs of some new testing architecture would reduce pre-release costs. Maybe it actually increases pre-release costs. Same thing on post-release. So kind of testing some of your own assumptions is very important to making sure that some of these early thoughts are useful. So costs of reducing patching, costs of reducing, reduced costs of evaluation, and then also obviously starting to think about consumer satisfaction and willingness to pay. So if you've got more time and effort, go in and actually talking to customers. If you don't, setting some ranges. We think customers might change their kind of satisfaction, willingness to pay by X percentage. If so, that makes this worthwhile. Here's the threshold. We think we can meet that threshold. So coming up with some metrics to basically help think through this process. Even if the end result is not an end number that says this is how much the benefits are going to be, if you set some ranges for the different metrics, the different cost metrics that would affect different stakeholders, that helps with your decision making, because maybe your best case scenario is outside of one of those ranges and you know the process, the investment doesn't make sense. Okay, so then collecting the data. So going out, talking to staff, going out, calculating salaries, calculating, again, based on the time available, number of staff involved in something, time spent on things, as much information as you can to understand the current situation and also what the situation might look like in the future. And again, the deeper you can get into this, the better, but that's time spent, right? So the more, ideally, this type of information is available, is readily available, so when these types of projects or investments are thought about, you go to a kind of central source, you get that data, and you can run this fairly quickly. If that's not the case, certainly on salaries, that should be the case. In terms of time being spent, that's a little more difficult, right? You might think you know how long is being spent on a certain activity. It might be longer, it might be shorter. It might be a little more nuanced. So those are things that you would dig into. And then on the benefit side, some of those things, again, are setting ranges for the potential benefits, doing that from the investment standpoint, but also asking the potentially affected stakeholders what the benefits they think they would see. And those may match up, they may not. And then obviously going out and talking to whoever the end user is. So be that home users of some product, be that corporate users of some product, going and actually getting some feedback to, again, test your assumptions, and if more time is available, actually coming up with dollar figures, coming up with levels of satisfaction, when people would buy or when they would be more satisfied or less satisfied. And then what's the likelihood of success? That's obviously the most difficult question, and especially for smaller investments, I'd recommend just setting ranges. So if the likelihood of success were below or above this range, we do it or we won't do it. And then in some respect, you have to kind of make a call there. But at least if you have the rest of this information on what the costs and benefits would be if successful, then you can make a better decision of what that threshold should be. Versus what traditionally is done in situations like this. A research team might say, okay, we think this is a complex problem that needs to be fixed. It's going to cost us this much to do it, and there's this much likelihood of success. And those are the only numbers that are oftentimes used in these type of situations. But if you have the actual cost-benefit numbers spelled out, you can make a much more informed decision. Okay, so analyzing the numbers, and this is, again, a very simplistic example. You know how much the research project should cost. You separate out different factors of what's being spent today, what the price of a certain product is, and then you look at how those costs are going to change, how that price is going to change, and you decide. You decide how to invest based on those numbers. It's very simplistic, but because each of these components can be so difficult to estimate, oftentimes people just scrap the whole thing. Whereas if you spend a little time on each one of these components, you really can improve your decision-making dramatically. Okay, so some key takeaways. First thing you should do is make a list of all the stakeholders, all the costs, all the benefit categories, and try to make sure you're not forgetting something. Think about who's going to be affected, how they're going to be affected, because normally someone is forgotten about. Some type of cost category or potentially benefit category is not thought about. So as much time as you can spend on thinking about all of those factors, you're only going to benefit the decision-making. And then think about what you can control. So some of these assumptions I talked about, there's sometimes things that you really aren't going to be able to estimate. You shouldn't spend a lot of time trying to estimate them if you're fairly sure it's going to be a very long process. And it looks like I had a typo on my slide there. All right. So the role of government. Well, let me just stop there. Any questions kind of about just the decision-making, investment decision-making process?
So I understand that works maybe relatively well when the chances of success, when it's a product group, and in some sense it's the feature set is clearly delineated and scoped, and effort is clear, and customers are clear. If you think about basic research, then that's a much more chaotic process where in some sense it's not even clear who will be the person benefiting.
Mm-hmm.
So do you see that this paradigm is also applied in basic research labs, maybe RTI in some parts, or does RTI apply it for all its projects?
So I would say the general framework can work for any project. Now, in a basic research project, you might not have that end number. What instead you might have is only a threshold, meaning that you are starting this project, and you still, I would suggest, should list off who might benefit. Who are the stakeholders that might benefit? And if the project, if the success of this project, if it's successful, and one of those groups would benefit enough to justify the investment, then maybe that's your decision right there. But without thinking about who those customers are in any fashion, I think and certainly the level of the investment matters as well. But I think by thinking about those customers and thinking about a low end, if one of them benefits, would that be enough? And also thinking about the negatives, right? So thinking about who would be negatively affected if this is implemented, and whether that negative impact would be so much that you shouldn't make the investment. So really setting baseline thresholds of a minimum level of benefit, right, and a minimum level of harm in some sense, because some things are going to negatively affect certain groups internally and externally, right? So setting minimum benefit thresholds and maximum harm thresholds, and trying to see if the investment would fit somewhere in the middle. That gives you a basic framework that allows you to think about basic research with some of these same thought processes.
Thanks a lot.
Yep.
Quick question.
Sure.
So in your experience, like what you just displayed, there's a lot of estimates going on. In your experience, have you seen groups that go back and then revisit those estimates later to kind of say, okay, were we close, were we not? Is that done? And if it is, what do you see? Are they close? Are there mistakes, common pitfalls that people make when making estimates?
I think it's very, very rare for a private company to do that.
So it's like
Because everything's forward-looking, right?
Okay, so the decision was made, and there's no sense of like maybe we can form future decisions by.
I would certainly say that there would be benefits to doing that, especially larger decisions. I think would greatly benefit. Obviously a really small investment decision that you made and you decided to go or no go. If you no go, you're not going to look back at it probably unless you see an environmental change. But if you decide to go for an investment and it either works or doesn't work, and it's large enough, I think there would be a huge benefit to looking backwards and trying to see how that might affect your future investment decisions. But I haven't talked to many private companies that are doing that. The government does, and I'll talk a little bit about some of their looking backwards and looking forwards. But I think more private companies could benefit from that, even if it's a simple look, right? Just a quick look back and say, okay, were some of these numbers roughly what we thought they were going to be? Why might we have gotten it wrong? And then the next forward-looking decision-making process could benefit from that. Okay, we'll move into talking a little bit about the role for government. So first, a little bit of background on why the government might be helpful, why it might be useful for the government to get involved. So I'm going to talk about a few of these different economic phrases here. So cost externalities. If I maintain an insecure, I'm going to use kind of security as an example to talk through some of these. So if I maintain an insecure computer, other people are hurt, right? So potentially, if my computer is insecure, it might be used to attack other people. But that doesn't hurt me at all. I don't bear any of that cost. So because of those costs that I'm imposing on people external to myself, that's a cost externality. If the government, for example, put a tax on my ISP and said that they had to help secure me, then that would help to internalize some of those costs. So sometimes that's an example of a role of the government being involved in internalizing a cost externality. Pollution is a common example of this, right? When I pollute something, when I run my car, unless there's a tax on gasoline that tries to internalize that, I'm polluting the larger group, the society, but I'm not paying that cost. Taxes on gasoline help to internalize that cost. Spillovers or network benefits are another type of market failure. So if ISPs, software providers, hardware providers, make more secure products, they may not receive all the benefits. So you may create a very secure product, but your customer may not be willing to pay for it because the benefits may be spilling outside of an individual customer, right? So if you make a Windows more secure, for example, it's going to benefit more than just a single user. It's going to benefit other people that are then not attacked by that user. So one user may not be willing to pay for the cost that it took to make that more secure. Let's see. Do the close it. Yeah, okay. No problem. And so the government could potentially subsidize more secure software by, and this is just an example, requesting more secure software themselves, being willing to pay a higher premium. So this is kind of the government as a buyer model. The government did this a little bit with IPv6, where they said, we want products to have IPv6. We know that could cost a little bit more. We're willing to pay it. So they bear some of the cost of implementing a new feature, and then the price should eventually drop as the product is then offered to a larger group of people. Information asymmetries. So this is essentially saying that not everyone has the same information. That causes a market failure. So in the example of security, consumers don't always know the cost they're imposing on other people. They also don't know how to increase their security. They don't know how to compare products, which is more secure, which is not. So they're not well informed enough to make a good decision on the security of products they're buying. Software makers don't have perfect information. They know more about the quality and security of their products, but there's not a good kind of system in place to allow that information to be shared. So the government potentially, and this hasn't happened in security in an effective way, but it has happened in other ways. The government or nonprofit organizations can get involved and help to standardize or provide an evaluation framework so that comparisons can happen. So UL, United Laboratories, is an example of a nonprofit that helps to kind of put a stamp on something so that people know it is of a certain quality level. So in security, that's something that people have talked about for a while. It's obviously a lot more difficult because of the change in security environment, but in some sense, creating a way to decrease those information asymmetries would be useful in matching up the supply and demand based on security features. Another way to do that to improve the situation would simply be by education. So educating corporate users, but probably more importantly small businesses, home internet users, about security so that they can make at least a little bit better informed decision than they do today because they would have more information and might align those supply and demand a little bit better. Okay, and the last one, the weakest model. So this is essentially saying that there are groups, particularly in security, home users and small businesses, that are particularly not well informed, not financially able to invest enough. The costs may, regardless of their knowledge, they still may not have the money, they may not have the resources to be able to invest sufficiently for society, so they may invest at a socially suboptimal level. So there may be a role for government to help these weakest links by subsidizing in some way, by education, something to help bring their private level investment up to a level closer to the societal, the socially optimal level of investment. And so all of these things influence the market supplied of trust. So these are just some examples of why government might get involved. And here's some ways governments can get involved. So at the top level, government could say, industry, you are solely responsible for this. That's the regulation model. Liability in terms of kind of legal liability can be imposed, which obviously doesn't exist for software in most places today. But liability can be used to establish that framework, which would then get insurance involved as well. Standards and best practices, this is where NIST gets involved. They set standards and best practices to try to improve information flows. And then research and development, so the government invests in NIST and other parts of the government in research and development to help improve security. And then government as a buyer, as I mentioned, where they just say, we want secure software, we're willing to pay more for it, please make it and we'll buy it. And then they help create a market that may not exist for more secure software. So in this software assurance world, I think there is a need for government to stay involved. But what that actually looks like is tricky. Regulations are certainly very difficult. They tend to be prescriptive and flexible. Insurance markets and liability, legal issues in the software space is extremely difficult. So figuring out what the government's role is, I think the government as a buyer has worked in some cases in the past. That may be a model that they want to pursue more. Right now, though, the government is, specifically related to security, is looking to get more involved in what private companies are doing. There are several current pieces of legislation in which the government could have a much larger hand in what private companies are doing with their products. So that could be coming, but I don't think enough research has been done on what that exact role should be. So just thinking about kind of some of the misalignments in the software world. So developers are obviously going to, and this is very simplistic, but software developers are obviously going to supply what maximizes profits, whereas users are only going to pay enough for what they perceive as their benefits that exceed their costs. So thinking about these kind of trade-offs from a social perspective, from a government perspective, you want to create a structure where these things can align better. Okay, so, and I'm going to get into this a little more at the back end of the research, but I think there is a large role, particularly in the security space, in the trustworthiness space, quality of software, to do more kind of analysis, both from the private perspective, but also from the government perspective. For example, what is the total cost of ownership for users? How much does it cost a user to own a piece of software, to maintain a piece of software? What are the testing costs within an organization, outside an organization? And by organization, I mean a software producer, software company, versus within a user community. When are users, or what are users most able to evaluate the time of purchase? This gets into that information asymmetries problem I talked about. So not a lot of research has been done there. Obviously, it's an area that I think it's very obvious that there's a lack of information, but figuring out what information is used, how it's used in other fields, I think could benefit this field. And then what are developers able to appropriate? What type of, how much can you invest and then get that money back in trustworthiness? How is that money recouped? Can trustworthiness be used simply as a branding feature? Is it something that you then put a stamp on and say, we are secure? Or is it better as a separate business, a services model, that sort of thing? So thinking about those issues from an economic standpoint, I think is a useful way to think about trustworthiness from the private perspective.
So,
questions, yeah.
Maybe one question. So what recently happened is that the world is moving to app stores, and part of that model is in some sense the easy way to distribute the software, but another is also to establish trust. I think competitors have done a very good job in their app stores to make sure that the software has a certain quality, and others don't have the same kind of rigor in their acceptance process, and you see in some sense many more software failing, which leads then to missed, let's say, that there's no longer trust in your platform. Have you looked into the change that comes with the rise of app stores, how that changes with respect to trust and knowledge?
Yeah, so I can't say that I've actually done research in the area. I will say, though, that the app model is obviously creating much faster reactions. So if I install Windows on my computer, it would take me a long time, many crashes probably, before I decide that I might want a different platform. Whereas with an app, the numbers I've heard are somewhere between kind of 2 and 3 times something crashes or something doesn't work, and I'm going to give up on an app. So the timelines for something to work are dramatically shorter with an app, particularly a free app. Given that a lot of apps are free, a paid app, it's a little bit longer. People are willing to stick with something a little bit longer. But it definitely changes this whole model dramatically. And I don't think there's some data you can get from these app stores to kind of understand how long people keep a product before they stop using it, that sort of thing. But I haven't done more research into that area. Any other questions on the role of government? All right. So I'm going to jump into to some of the studies we've done. A little bit about kind of NIST and other government agencies are like this, but some of the kind of ways they use economic analysis to think about their planning. So one is strategic planning. What should we do in the future? Or I guess so we'll start at the left side here. So what's the role of kind of policy analysis? When should NIST get involved in something? So what is the economic rationale for NIST to play a role in something? So They do studies and kind of think about why the government should get into a certain space. That's kind of step one. Once you've decided there is a role for government in a certain space, you do kind of strategic planning. What should that role look like? What are kind of the potential benefits of going after a certain space? So for example, we're doing a study right now for NIST on cybersecurity, looking at, from NIST perspective, where should they invest their dollars to potentially have the greatest economic impact, right? So not just what are the most complex problems, not what do they want to work on, not what are they being asked for, but where specifically, if they solve problem A, B, C, or D, where could they have the greatest economic impact on industry and on society? And then after they kind of use that in terms of actually making investments, NIST does work on retrospective analyses. They look backwards and say, we invested in this standard, this new policy, this new standard practice. What was the benefit? Did it actually benefit people the way we thought it would? Did it not? Should we invest in something more in this area? So they have a very kind of cyclical analysis. They don't do this for every investment they make, but they pick and choose investments to do this. And I think this structure, even thinking back to some of the kind of private investment ideas I talked about before, even if you don't have time to do this in a very rigorous manner, thinking about investments in this fashion I think is very useful. Starting with, from a private standpoint, why do we want to invest in this? A very basic question, but making sure you have a clear definition of why you want to invest in something. Making sure you have a clear definition of who would benefit and who would be negatively impacted by a decision. Then you make the investment based on that determination, and then afterwards saying, did we do a good job there? And not doing that with every single investment, but picking investments of a certain level, and doing that I think would have great benefit to private organizations. I think, and certainly NIST I think has really bought into this model and does a lot of work in this area. I had hoped actually that Greg Tassi, the chief economist at NIST, was going to be able to join me today, but he wasn't able. So hopefully he'd like to come back and maybe make another presentation to you all in the future. But I'll talk about a few studies that we've done for NIST that fit into these two boxes. So two of them are retrospective, and one of them, well, IPv6 was kind of a mixture, prospective, retrospective. Role-based access control was retrospective. And then software testing, a study that I think will be particularly of interest, despite it being a little bit old, was prospective. What's the potential benefit of changing the software testing framework? So I'll go through the first two relatively quickly, spend most of the time on the software testing study. So IPv6, we were asked by Department of Commerce, the NTIA, and NIST to conduct an economic impact assessment of IPv6. We went out to both the software community, hardware community, to understand what the cost of actually implementing IPv6 would be. So how much would it cost for IPv6 to be integrated into current products or future products and services? And then also went out to users and asked them about the adoption costs on their side. We also talked about what some of the benefits would be. The benefits were a little more speculative, particularly because security was one of the benefits that was talked about. The other benefits included kind of reductions in certain networking costs that companies might have, as well as on the production side, hardware, software producers might have lower costs of maintaining products once IPv6 is fully adopted. And so the numbers we calculated, it was a fairly easy decision that IPv6 was a good decision for society. Now, this does not mean that any individual organization sees a positive return on investment from IPv6. What this means is, as a society, we found that it made sense for IPv6 long term. That doesn't mean there weren't going to be lots of potential problems in the short term, security problems and other problems, but what we found is in a base case, which means what we heard that people were saying how they were going to start implementing IPv6 starting in 2005 over the next 5 or 6 years, as well as an accelerated case in which they did it a little bit faster. We found it would cost around $25 million to implement IPv6 within a base case, and $76 million if we ramped up all the timelines by a couple years, and they tried to do it faster. For the most part, it seems like every product these days, looking backwards on this study, has IPv6 integrated. The use is still not as high as people were saying it was going to be at that point. So that's one of the studies we did, which we were looking kind of forward and haven't done a backwards look. But I think it would be interesting to kind of look backwards and see how some of this has actually panned out. RBAC, we actually did a study on role-based access control in 2002 that was mainly prospective, and then came back and did one for NIST in 2010 that was mainly retrospective. And largely the benefits ended up being much greater than we originally anticipated in 2002. Role-based access control, if you're not familiar, is a way that organizations can decide how to provide access to different resources within an organization based on their roles. And it has a whole framework for how this works. Lots of products and services have been kind of built on the RBAC framework. And so we went out and surveyed organizations that create those software packages, as well as organizations that use them, to find out what the benefits of the RBAC framework existing to the companies that made products, as well as users of RBAC. And if RBAC didn't exist, when some of these things might have happened without NIST's involvement in RBAC. Because before RBAC, some of these kind of processes were happening on their own. So we try as much as possible to not just say, for example, RBAC versus no RBAC. We try to say, okay, if RBAC didn't exist, what would have happened otherwise? Some type of role management would have happened anyway. So it's not just this baseline of no role management versus RBAC. We try to set a baseline of something that would have taken a little bit longer to establish versus NIST investing in RBAC and what that ended up doing. And we found a pretty enormous benefit of $6 billion from the RBAC standard itself, about $1 billion of which was attributable to NIST based on their level of investment as compared to other people's investment of time and resources and that sort of thing. So quite a large benefit from that investment that they made. All right, so moving to sure.
So RBAC hasn't been adopted everywhere. So why, if in such that the net benefit is so astonishing and good, why is adoption then slow?
Yeah, so again, some of these benefits aren't totally accrued by an individual organization, right? So different organizations, different players tend to benefit more. So this doesn't mean, and I don't have the breakout of this, but a lot of the benefits did go to some of the makers of the products, right? So an individual company, and this is aggregated across all U.S. organizations, right? So an individual company adopting RBAC may not see an enormous benefit. It may be relatively small. When you add it up across all industries, it becomes very large. But for an individual company, number one, role management doesn't work in every company, right? If you have an organization that's that has lots of roles, it has many roles, people change roles frequently, it's not a very systematic a way of kind of people being in different kind of employment categories, RBAC doesn't work as well. So number one, you have RBAC that doesn't work in some places. Number two, where it does work, it may not be an enormous benefit to an individual company. It may be an incremental benefit, or they may not see all the benefits themselves. That's the other thing. And this goes back to the kind of investment decision making we talked about before. Sometimes people don't see all the costs and benefits of an investment. So they may just be thinking about, and this is typical, who would implement RBAC? It'd be an IT group. So that IT group may simply be thinking, if we adopted RBAC, it might reduce a little bit of our cost. But they're not thinking about the users outside of their organization. So for example, if RBAC were implemented, it may be easier for me as a staff in that organization to access resources without having to ask 5 people to get that access. But the IT analysis of whether to use RBAC is not going to incorporate that. Right, so there are a lot of reasons. Those are just a few. Yeah. Okay, so let me talk through this study on software testing. So basically, NIST came to us and said, it seems like software testing doesn't always work. There are a lot of bugs after a product is released. Where are some of the costs borne within companies? And for people that have thought a lot about this within your companies, some of these numbers may not seem that shocking, particularly on the software development side. We also collected some on the user side that may be more of interest. But NIST was interested in both. NIST was interested in what are the costs within an organization, how do they change as you go farther along the development process. Once a product is released, what are the costs? What do those look like for users? So we went out and collected information on both sides. So similar to what I was talking about with RBAC, we do this kind of counterfactual scenario. What's going on today? What are current types of investment today? We did kind of a hypothetical improvement. So we said we kind of shifted, and I'll show you what this means. We shifted some of the times in which different bugs might be found marginally, and then we shifted it much more significantly to the very front end of development to look at kind of a halfway case in a perfect world, you might say, development case in terms of when bugs are found. So those were our kind of counterfactuals, the what-if scenarios we worked with. For both of those, we collected information from developers on how that would affect their costs, as well as from users in terms of if fewer bugs came out within a software product, how that would affect their costs. And then for this, we talked to specifically the automotive and aerospace industries and financial services on the user side, and then talked to software developers, obviously, on their side. Okay, so very basic analysis of software incentive structure for software companies. Again, this is information that I'm sure is obviously pretty straightforward for you all. This is how you make money, maximizing revenue, keeping testing low, keeping production low, and maximizing, keeping after sales low as possible, right? So maximizing all that. So we wanted to look into each of these pieces and see how they were changed by when bugs are introduced and when bugs are fixed. Okay, a little bit more, and I might breeze through this, but this is, again, just kind of some background on the marginal cost of finding on going after bugs and when they're found, when costs are incurred, how that affects sales prices. So the kind of marginal costs and marginal benefits, both to software makers, but also to end users. So as we talked with different software makers and end users, we made sure we had some of this kind of conceptual background before we went into things. And understanding, I think, the gaps between what a consumer would want versus what the company wants is something I think that is still an existing question for debate. I think understanding these issues is something that I think more has been done since we did this study, but I think some of the kind of thought processes, some of the conceptual frameworks are still, more work needs to be done. Okay, so defining these two counterfactual scenarios. One is this enhanced framework of reducing or making sure errors are found sooner. End users experience a reduced number of errors. So on the software testing side, we say you find things a little bit faster, but end users still have some problems. Then we looked at kind of a perfect infrastructure testing situation where all errors are found in the same development stage in which they're introduced. So whatever development stage that is, they're always found in that stage. This is obviously perfect world and probably extremely expensive. Then end users experience no errors, right? So what are the total costs that end users are currently spending on dealing with bugs? Okay, so some of the basic assumptions, the same number of bugs still occur. So we kind of assumed, based on what was going on in 2002, that there wouldn't be some major trend changes in bugs, right? Wouldn't be some major trend changes. So we kind of said we're going to look at today and what's been happening in the past year. Similarly, the improved infrastructure, we said that didn't change. If you improve the infrastructure, that doesn't change location of where the bugs are introduced. So there's still going to be bugs introduced in each phase. So we're just talking about when they're going to be fixed, when they're going to be solved. And so we set up those two scenarios I talked about, an improved infrastructure and what we call a perfect infrastructure. Okay, so as we went out, we tried to find out the distribution of where those bugs are found. We tried to determine the cost of both finding them and fixing them, and figuring out kind of a cost as a function of how long it takes to find the bug. And I'll kind of skip through some of this. Okay, and these are, and I'm sure some of this has changed, but these are kind of the broad categories of development of software that we use to establish when bugs may be introduced and when they should be fixed or when they could be fixed. So this is the model that we developed based on interviews with companies working in the software field. And then I'll show kind of moving forward what we heard in terms of when bugs are actually introduced and when they're solved. Okay, so the total cumulative distribution of error detection here, obviously it grows very dramatically, fairly quickly within kind of the implementation and unit testing stage is what we heard through our interviews and surveys. And then kind of levels off, and then obviously there are some bugs that happen after release. And this framework is aggregating software development very broadly versus being very disaggregated. Okay, so this is typically what we heard in terms of the types of software we were looking at, where different testing costs were being incurred within an organization. So the costs, if you look on the left here, you have the average cost per bug, and it goes up over time the farther you get along in the process, and then the distribution of where bugs are actually detected. So this is kind of the framework we came up with. And once we had some of these basic assumptions, once we had kind of cost per bug, where it happened, the distribution of when it happened, we could then basically run all of our analyses on how this could change, right? How the different cost frameworks could change. So the rest of my tables will kind of go through what we saw. So we said, okay, in this kind of this improved implementation scenario, we just shifted all these curves, right? So if you found things a little bit faster, you could lower costs by a certain amount, and thus overall potentially reduce your costs of detecting those bugs. And this is you're seeing a kind of a combined cost of you're spending less when you find it earlier, but then your end user is also incurring less costs because there are fewer bugs coming out of the system.
So does that mean that the time for the phases actually gets longer because you fix the bugs earlier? So the 15% to 20%.
So these don't necessarily mean that these phases are taking longer. The horizontal here is the percentage of where bugs are detected. So that's not time necessarily, right? So that's a fraction of the where bugs are found. So what you're doing is you're making a higher percentage is found earlier in the development process, right? Okay, and so essentially we want to kind of think about so we kind of dug into the user side of things. I think this is an area that more work needs to be done on. But what are the actual user costs, right? How's the user impacted by not having buggy software? So they have failure costs. Obviously, if something breaks, their system goes down. What that does to them. They also need to have redundant systems in case those failures happen. So there are kind of a variety of costs, and pulling all those together in terms of understanding willingness to pay for reductions in bugs conceptually is fairly straightforward. Now, actually figuring out what people are willing to pay is much more complicated for increasing the quality of software. Okay, so what we found in terms of time being spent, so this is the hours to fix a bug based on the point of introduction. So on the left you see where a bug was found. On the right or top there you see this, on the left you see where it was introduced. The top you see where it was found, and you see the time it took to actually fix a bug. So as you see it kind of grows over time based on how long it took to find a problem. Okay. This is given that a bug was found, where was it introduced, right? So obviously if you introduced it in requirements, 100% it's found in requirements. So this is just a breakout of where things were found. So we take these numbers and we basically start kind of adjusting them and seeing what the economic impact is. Whether that's an economic impact that is feasible or not, kind of coming up with ranges of what those impacts would be. So here's our scenario. So we see kind of where bugs are found. We have some of the numbers I showed you on how the different costs relate to those areas. So we came up with this improved infrastructure and this perfect world infrastructure. So improved infrastructure, you see we basically find things a little bit earlier. That ends up shifting the average because we know how much time it takes to take a bug, to find a bug within each of these areas. We know the cost per bug and hours for each of these areas, so we can come up with an average number of hours to fix a bug. And so if we improve the infrastructure marginally, you see a reduction. If you go to a perfect infrastructure, you see a much larger reduction. So again, all these numbers up here at the top, because these are just set numbers of testers, salaries, certain things. But down here at the bottom, you have a percentage reduction in the average hours per bug, right? And so the savings ends up being quite a bit for developers in terms of cost savings for finding things a little bit earlier. It's a very simplistic situation here. Okay, so this is where we went out and looked at end user side. So we looked at major errors, minor errors. We looked at decision costs. We looked at installation costs, maintenance costs, redundant systems costs, and kind of added up how much banks spend in the financial services sector on dealing with potential bugs, potential errors. So this is a breakout of what they were able to estimate. Again, this is back in 2002. I'm sure the numbers would be, or I would think they would be a little bit lower at this point. But you can see where most of the costs are. Major errors comprise a large majority of the costs. You see a little bit of a difference with banks and credit unions, but pretty significant costs that they're seeing. On software developers and users within the financial services sector, you can go find this whole report online, and it has a lot more information on each of these different sectors if you want to dig into it. But I pulled out a few key numbers here. So if you move to this kind of better system, you start to see, well, I guess the way this is set up, on the left here, this is the total cost of an inadequate software testing infrastructure. So what this means is no errors go out to end user. So end users, you see the numbers there at the bottom of 789 million and 216 millions are if end users saw no errors, no bugs. It's the total cost that they spend on bugs. Up in the software developer side, those are the costs that were estimated with router and switch developers and with clearinghouse software developers in terms of how much they could save if they then started doing testing in earlier phases. And then over here to the right, this is kind of the marginally improved system. So software developers look and try to do things a little bit earlier in the process. So some of their costs are reduced. On the user side, the cost reductions are smaller because you're still reducing errors. It's just a smaller number of errors that actually get out. So again, for a company like Microsoft, the software developer numbers, it's not as simple a story, right? These guys, especially back in 2002, they had very, I would say, kind of unsophisticated software testing processes, right? So simply thinking about where they were putting their software testing costs, they could very dramatically start to see a change, and they started making changes after this study. That's obviously something that's very different within Microsoft. I feel, pretty comfortable that you guys are calculating these costs and probably have a pretty good sense of where those numbers are. But the user side is an area that I think still is very not well understood in terms of software users and what their potential impact of bugs are, how that changes in terms of when they're introduced, how they're introduced, both for home users of any type of software products as well as corporate users. And the framework, I think, here still fits. Okay, so future research needs. So these are just a few thoughts on kind of software quality, software security that may be of interest. So as I mentioned before, I think kind of total cost of ownership for users is an area that needs a good bit of work. The incentive structure, the cost structure for software developers and companies, which is very different, right? A software developer may not feel the incentive that the whole company feels for investing in additional testing, in additional coding. And then thinking about kind of information and risk issues. So let me step through each of these a little bit. So total cost of ownership. So what are the costs to the user of inadequate software? If you don't have good software, what does that actually mean to an end user? What can I do? What don't I do as an individual if I don't have good software? How does that change what I'm doing in terms of services I might interact with, both provided by the same company, provided by other companies? How does that impact me as a company in terms of what I'm able to do if something crashes? What is that? Does that mean I lose business? Does that mean I'm not as productive? What are the different impacts there? And then generally how much people are willing to pay. What is the cost of more secure higher quality software? What are people willing to pay to get more secure, higher quality software? So digging into that further, taking business activities and productivity and saying we're going to hold those things constant, and then thinking about what the different cost categories currently are of owning software, right? So you have to search for software, and some companies spend a lot of time on this. They pay companies like Gartner and other companies like that to understand more about, how good somebody's software is, and is it going to be better, and should I wait or should I buy now? So that's actually a huge amount of money that companies spend simply on searching, right? So can that be reduced by some change in quality or some change in information flows? The actual purchase and license fee obviously may go up, should go up if quality is increased. Then additional support fees. So most companies obviously are charging their end users some type of support fee for working with them. Could those go up? Could those go down if the purchase price or license fee goes up? So for users, thinking about kind of what all these costs are. Then testing, that's what we talked about before, kind of what people are spending when they have problems, testing beforehand. Certain companies spend lots of time testing products before they even release them to their staff, and then obviously fixing problems after they come back. Integration issues, maintenance issues, indirect costs. So if I, as RTI, if we adopt some new software and it causes us something not to work and we can't provide our customers some product or service in a timely fashion, we look bad. That makes us then think badly about the software that we purchased. So reputation risks for the company as well as for the software that they purchased that they may blame. So thinking about the benefit side is quite difficult. Thinking about all these costs of owning software is at least fairly simple to list all the different factors. Estimating it isn't totally simple, but is something that can be done. Estimating the benefits can be quite difficult. So if I'm more productive, if software X moves faster, if there are fewer clicks for me to get to what I want, if I can implement some new product faster, if I can purchase another piece of software that I couldn't have purchased because this core software is better. Those are much more difficult things for users to analyze and for companies selling software to users to analyze. But particularly productivity is something that I think can be assessed, but software companies aren't doing that, and neither are end users. Largely, I think companies that are adopting software are doing it out of an IT framework, and many of them are not thinking much about the impact on their users. So that's something that I think software companies could do a better job of saying, if you buy this software, not only will it save you IT costs, it will save your customers X number of minutes, hours per day that they currently spend because something's not working well, X number of minutes, hours per year when something crashes. So communicating those benefits, especially to corporate users, is something that I think could be done much better, helping corporate users think about the whole process of their total cost of ownership. Because largely they think about it in an IT framework, and thus software makers do as well. But I think selling more secure software, selling higher quality software should entail convincing and talking to buyers about what those total benefits might look like. Okay, and this can be thought of, so willingness to pay, this can be thought of from a business standpoint as well as from an individual standpoint. Thinking about actually how much people are willing to pay for more secure software and what features or higher quality software that may include security, and what features of quality people are actually willing to pay more or less for. Is security something that people care about? Do they know enough about it to care? Do they care about something running more efficiently? Understanding exactly what different types of end users are willing to pay or what the benefits would be to them of adding new features that are part of additional quality is something that's needed more from the software standpoint, but also needed more from companies themselves. Because again, they do so many things from the IT standpoint. They don't always know how much their users may or may not benefit from additional security. So thinking through those issues, and there may be a role for government here. in terms of particularly security I talked about. And I'm certainly not a proponent of just slapping regulation onto something because there's certainly a lot of consequences to doing that. But there could be a role, particularly as I talked about before, government as a buyer, for example. The government could request, and they're doing this right now, more secure systems, more secure software to help pay for some of the R&D work that companies would need to do to make make software higher quality, possibly more secure, so that then that could filter down to other customers. And then thinking about what the trade-offs are. So, how much might price have to increase from a software maker? What do you lose by being first to market, right? So you may have some product or some feature you want to release. If you release it too soon, it may not be as high quality, but you may get some users out of it. Thinking back to the kind of app model that's forcing people to use something and maybe drop it faster. What's the kind of quality threshold that someone's willing to accept before they drop you and move on to somebody else. So thinking about all the trade-offs between price, first to market, and quality, a lot more needs to be done there to understand from both the user standpoint what they should do, but also from the software developer standpoint what makes sense. And there's no one-size-fits-all for this. Every product line, I think, is going to differ. Every customer line is going to differ, which makes this a very complicated issue. However, if you think about all these factors within each of your product lines, I think you'll uncover some things that may not have currently been thought about. Okay, so software developers, what's the cost structure? What does it cost to actually, if more higher quality software were desired, if more secure software were more desired, what exactly would that look like? How much does it cost in terms of testing, that sort of thing? I think these are things you all probably have quite a good handle on. But if not, you should, for each of your product lines, understanding what all the different cost breakouts are and how those different cost breakouts could be tweaked. So it doesn't mean you just have to say, we're going to increase the quality of software. There may be a certain piece where it is cost effective to increase the level of quality within some certain testing component or development component that may meet the user's willingness to pay, right? So you may be able to match up the willingness to pay with a specific increase in quality, but it may not be that everybody needs to increase what they're doing. Okay, and then thinking about this from a corporate perspective, how do you make sure you're going to keep customers? How are you going to make sure you're going to keep partners and relationships by your level of quality? So it's not just the purchase decision of we want somebody to buy our product. It's now we don't want them to drop our product. We don't want this institution to drop our product. We don't want this partner who sells our product to drop our product. How do we figure that out? So it's not just what's the time that's being imposed on an end user? How do we minimize that? It's when do people think about switching products, and when do partners think about switching vendors they're working with? So those are obviously very complicated decisions that I think quite a bit of work needs to be done on from an external perspective. Not a lot of research is really has been done in the quality kind of trade-off standpoint, both from companies' perspectives as well as users' perspectives. And then finally, think about some of these information and risk issues that I've kind of talked about throughout the discussion here. How can we improve information flows? This is a role I think that software makers can do a better job of. I know it's a little tricky because if you, for example, put a stamp on your product, you introduce the possibility of liability issues coming into the situation, and courts may be getting more involved than they are now, which could be problematic. But thinking about ways to better inform users about the quality you're providing, even if you're not providing a perfect product, I think would only benefit software companies, because right now there is not a lot of information flow. I think that creates creates from the user side a lot of thought that companies are just pushing out buggy software without a lot of thought. So increased information flows and understanding, doing more kind of analysis of those communications, doing kind of surveys and interviews to understand, even if you're not going to change the quality of a product, how can you communicate better the quality of that product in a way that customers understand that the price they're paying is an appropriate price, or if they'd be willing to pay more for that product if it were more secure. So understanding those trade-offs, understanding how to communicate better is a role that I think the whole software industry needs to do a better job of. Is there a role for third parties in terms of analyzing, evaluating software quality, software security, and what might that be? Is there a role for government in helping in that? And then are there kind of licensing models that could be changed? So a software company like Microsoft licenses their product to an end user, and there's normally kind of service agreements, right, that come along with that. If the product went out more secure, would companies be incentivized to pay more? So looking at kind of not just how much companies are willing to pay, but the total cost of ownership for companies in terms of both licensing as well as services, as well as their internal cost structure. Thinking about that from both sides is something that needs to be done more. And I think that's all I've got. Hopefully hit about right my 45-minute time here. So additional questions on, I know we asked a few coming through. I don't think we can get some from anybody else watching, but do you guys have additional questions here in the room?
So you spoke a lot about security. If you actually pay attention recently, then there's a lot about the implications for privacy of users. Have you looked into that space? For example, many people believe that if we are too restrict on privacy, then our ad markets doesn't work, and our ad markets and sometimes subsidize and sometimes the free software that we use on our search engines and so on. So how does sometimes privacy fit into this picture?
Yeah, I mean, I think there have been quite a few examples where companies have not been clear enough, and there's been a pretty significant backlash. So I think information sharing and clarity is the solution. If individuals know that their information is going to be used and thus they're getting something for free or something at a lower price, most research that's been done suggests that lots of users would be willing to allow that, would be willing to allow some of their information to be used in some way, not always, but some ways, to be able to have a free or reduced price. So I think it's all about information and clarity. I think any model could work. I think some countries are being a little too restrictive on what can be done with data, because I think that what should be done is it should be communicated what's being done with your data, and then users should be allowed to decide whether they want that and want the benefits, cost-free, that sort of thing that comes along with it or not. I think that's the perfect situation in my mind.
In those kind of scenarios, so for example, today, the default is, so right now there's the Do Not Track initiative that's going on. It seems like we're getting towards this the solution that the user will have the ability to opt out. Today, user doesn't even know, and the information are being subsumed, are being taken by the ad network, by the advertisers. And now there's going to be a button that's saying that the user may express that do not want to be tracked. What would be the right default? And what default would be acceptable? I mean, in some of these scenarios, there's also the question: is the user who wants the privacy, or is the privacy advocate groups, or is it the government?
Yeah, it's tricky because when you ask users, they want total control, right? So that there's pretty clear research on users want to be in control of their information. So I think it seems fairly likely that the legal and regulatory frameworks that are kind of moving in a certain direction are going to give users the majority of the control. The issue is communicating the benefits of allowance, right? So I think users, when you give somebody an opt-out and say, do you want your information to be shared, I think the research has been done shows that most people are going to say, no, I don't want my information to be shared. But if you communicate what you get out of sharing it, you get more tailored products. You get a free product. You get a highly integrated product, something like that. I think so. I think companies that are using data today on the web within products where they're tracking things, that sort of thing, I think a lot of work needs to be done to be very specific, very clear about why you should say yes. Because if not, most people are going to say no, and you're going to see some dramatic shifts in revenue streams very quickly for companies that rely on ads. And I mean, I've seen in my own interactions with different web services that companies are doing more of that. So certain web companies are saying, you know, you want to allow us to do this because it lets us tailor this more for you. And so I think that message is getting out to users. So the kick reaction of not allowing your information to be used may be changing. So 2 years ago, if you asked it, I think the vast majority of people would say no, I don't want my information to be used. Today, it may be a little bit different because people are starting to feel, I think, a little bit more in control, and they're also starting to see the benefits. So I think that communication needs to continue to get the balance right. But I think it seems like the government kind of regulatory and legal frameworks are definitely moving in the direction of giving most of the control to users.
It's also very tricky for the user to actually understand the implications, you know, how much their data worth, and where the data is going, and who they really trust as such. Even if, so I mean, even presenting all those information to the user can be tricky. What does it mean? Yeah, so it feels like the industry is coming to this junction point, trying to figure this out.
No, I think that's right. I think you're exactly right. And I think as much as you can, like I said, jump in front of it and try different ways of communicating, right? Try different strategies and see how people react. See if you can change people's opt-in or opt-out by different communication models. I mean, that's how it seems today, is that's the direction things are heading in. So it's not as much, you know, is that the right direction? It's more of how do we deal with the fact that things are going in that direction.
Thanks. Are there any other questions? Thanks a lot.
All right. Appreciate it.